Omar only wants to hear English, right, Omar? Yes. Do not corrupt him, please. Right, next lesson, cantilevers and further support. Find out shortly. Yes. Next time in physics class. Did you write this name down? Yes. Continue. Yeah. Okay. So here's a very particular turning force problem. You see these quite a lot, where you have one force up and one force down, and the forces are equal. The same with the bicycle, one force left and one force right. And this is a special type of system. So, if we look at it for a moment here, it's usually a wheel, and like I said, there's usually a force here, and there's a force here. And we'll call the distance in total capital D. And I want to know what's the total turning force. Okay? So, where seems like a good place to put the turning point?
D, the middle.
In the middle. Yeah. So, is this clockwise or anti-clockwise?
Which one?
Anti. And this one? Clockwise. What is the turning force from this one? No, hang on.
No, they're the same direction. What is this?
They're both in the same direction.
Anti.
Yeah.
They're both turning this way. Yes? Yeah. Okay, so what is the turning force from this one? What's the force? F. And the distance?
D over 2.
Yeah, and this one?
dr.
The same. Plus F times D over 2. So actually the total turning force is the force on each end, which we'll call an F, multiplied by D. So for example, if somebody's turning a steering wheel and they apply 10 newtons this way and 10 newtons this way, and what would this be? I don't know, 0.4 or something like this. The total turning force, I can do it quickly in my head, would be 4. It'd be 10 times 0.4.
Not like a theory.
It's just because it's such a common problem, rather than doing this every time, you can just do this straight away.
Unless they're different.
These will be the same answer.
It's a circle, so it has
You mean different forces? The forces.
Oh, huh?
Different forces are different. Like
Oh no, the forces must be the same.
okay.
Must be the same. This system is called a couple.
Okay.
It's a very common, special type of system. What's important about it is that these forces, they only rotate the wheel. They do not cause the wheel to move up or down. Because 10 minus 10 is 0. So the only effect is to turn the wheel. If they were not equal, for example, if you had an 11 and a 10, the wheel would turn and also rise upwards with a force of 1 newton.
So if you like, let's say you're holding a steering wheel and then this hand applies 10 and this hand only applies 5.
This hand will go out of the way.
No.
Because the wheel is stuck in the middle.
No. Yeah. Think about his question. There's the steering wheel. And you have 10 newtons, or whatever you said, 10 newtons here and 5 newtons here. So what should happen to the wheel? Well, it will turn, right?
Yeah.
Let's calculate the turning force. Let's say this is just 0.2 and this is 0.2, and this is the turning point. What's the turning force here? 0.2 times 10? 2. And here, 0.2 times 5?
1.
Yeah.
1. So the turning force is 3 Newton meters. So he is making the wheel turn by 3 Newton meters. What else should the wheel do?
Break.
It's supposed to move up
Yeah.
with how much force?
5.
5 newtons. But it doesn't, of course, because you're not that, I know you think you're strong, but you're not that strong, okay? So what is stopping the wheel? So, you could take the wheel and with this hand really hard push up and this hand lightly pull down.
Yeah.
Yeah, you can do this, but the wheel doesn't go so what is happening here? There's another force which you haven't found.
Centripetal force.
No, dude.
No.
Dude. Now I'm gonna start applying this 5-second rule to you. Not this. What's happening?
It's the thing
The screw that's holding the wheel and the center.
from behind.
The shaft, the wheel shaft, the wheel chamber. It's attached to the dashboard. So there's a reaction force down here of how much? 5 newtons. So if this is the wheel and it's attached to the car, there's now a reaction of 5 newtons. As you try to push up, this chamber will push down with 5 newtons. Yeah. So it's a good question when you think about it, because you can actually make it not the same. So why does it not move? The reaction from the chamber, the wheel shaft here.
3 Newton meters.
So it does still rotate with 3 Newton meters, because why does this not get added to this number? Why not?
So we just
That's a force with and that's a moment.
Why does this not get added to this in the calculation?
It's not in the same direction.
No.
Zero
Yes,
from the pivot.
it's through the turning point.
and
So it doesn't contribute to the turning force. It only purpose is to cancel the 10 here so the wheel doesn't move. Yeah?
so since they're going in the same direction, can we just add them up?
Which are
Like
going?
the 5 and the 10.
Not the 5 and the 10, but the 2 and the 1.
Yeah, well, aren't they the same?
15 times.
Oh, no, I wouldn't be thinking about it this way. Think about it as this turning force plus this turning force. Not this force plus this force. Okay. Anyways, this type of system is a special one. It's called a couple, and a couple is defined as 2 equal but opposite forces F that are a distance d apart and cause an object to rotate but not to move linearly, just to rotate. The total turning force is Fd, as we proved previously. So you might want to write this definition down, please. Whoops. Yeah?
Why do we call them opposite? They're both in the same rotation direction.
One is up, one is down. Down is the opposite of up.
Yeah, I'm
Up is the opposite of down.
really never knew.
I'm here to teach. This is why we call them opposite. Opposite in the vertical sense. You have this? Yeah. You can type a lot faster than handwriting.
Oh yeah.
They're the same thing. Turning point, the points where it turns. Even, correct me if I'm wrong, yeah?
Yeah, you're right.
Turning point is the point where it turns. Turning force is the force required to turn.
Yeah.
Yeah?
So you've explained what turning point is by using the word turning and point. Yeah. No, it's difficult to explain because it is a point and it does turn. So what other way can you put it? So turning point. This is why I resort to visuals for things like this. So with the door, this is the turning force. This is the turning point. Also called the fulcrum or pivot.
But there's another thing.
Well, there's two turning points really. Yeah.
And the third one, if you count the handle right. Yeah.
Okay, now there's not, because now it's just this. Now, got that? Yep. Okay, continue. Yes. Yeah. Next now. So now on to what is a cantilever. So these are cantilevers. And before I give you the formal definition, you should write the names down with the pictures because I know nobody knows these terms. So I want the pictures with the names in your book, please. We have a simple cantilever, a braced cantilever with a compressive strut, and a braced cantilever with a tensile stay. These are it's a simple thing, but difficult names. Okay. The next time you are at Sylvia's office, there is a cantilever somewhere near her office. I invite you to find it.
Do we get the prize for finding it?
Yes, and don't forget my post as well on the video also comes with a prize too. The first one who takes a picture and tweets it #StephenPhysics will get a prize. Yeah.
For more subscribers.
Yes, that's it. Yes? What?
Yes. Yes.
What?
Where?
That thing?
Yeah.
Oh, yeah.
No. I said the one at Sylvia's office.
Yeah.
There's a braced cantilever at Sylvia's office somewhere.
Braced is like in the middle, yeah.
No, braced means like supported.
Oh, okay.
Are you trying to draw the pictures there? Okay, have you drawn these with the names? Okay, you got that? So the formal definition, what exactly is a cantilever? So a cantilever is a rigid structural element. What does the word rigid mean? Yes, again? Give me another word. Yeah, give me another word. You got the right idea. Something else.
The opposite of fragile.
Yeah, opposite of fragile, yeah. So rigid means fixed, solid, hard, not fragile, not flexible, not easy to break, solid.
Not elastic.
Yes. So rigid, like this, solid. Such as a beam or a plate. Anchored. What is this verb? Anchored.
Stable from one
Yeah, give me another verb for anchored.
Held.
Hook.
Hooked, yeah. Held, hooked, attached. At only one end to a usually vertical support, like a wall, from which it's protruding. What's another word for protruding? Oh, now we've reached the limit of vocabulary, have we? Protruding?
Coming out.
Yes, sticking out. Look at all these great words now. So try to get this definition down, please. Got that all written down? Yeah. Protruding is a new word for you?
What was it again?
Sticking out. Maybe you want to write that down beside it or something. It's interesting because, as you know, in English, different subject areas would use different verbs, but for the same meaning. Like, so for example, here anchored means attached or hooked. So you might say, well, why don't you just use attached or hooked? Because anchored is the type of verb that would be used in engineering. The same with protruding. You said, why don't you say sticking out? Well, that's what you might say in general English, like day-to-day English, but protruding would be more the engineering word for it.
More academic, maybe.
More academic for sure, yeah. Again, rigid is more academic than solid. You know, you could say a solid element, but it's more academic to say a rigid element. Yeah. Okay, next. So, first question, I think you can do it, and then I'll probably do the next one here. So, the first one's to do with a couple. A woman turns the steering wheel by applying a force of 5 newtons down with her left hand and 5 newtons up with her right hand. The steering wheel is 30 centimeters in diameter. What is the couple? What is the turning force in total? So it should only take you 10 seconds to get the answer here. I know what you did wrong there. You forgot to change centimeters into meters. Yeah. Yes? What is steering wheel? Ask your friend here. He's very helpful.
The car.
Got it? Yes. Look at all these words you're learning today. It's great. That's great. Okay, what's the answer here?
1.5.
1.5 watt, eh? Just give me the units. 1.5 Newton meters. Okay. Now the next one is now a cantilever one, which I'll do. But what I want you to try and do is draw this problem. So it's a 40 centimeter by 20 centimeter sign of mass 2 kilograms is hung by means of a braced cantilever. The stay is 40 centimeters up the wall, and the other end is attached to the end of the cantilever. So you've got a sign like this, 40 by 20, and you put it up against the wall, and you have a stay here. I want you to try and draw this, and more importantly, I want you to try and draw the forces on the diagram as well. Then I'll solve it.
Do you suggest that we draw everything in the exam? Select pictures?
Oh yes. It'll make your life much easier.
the 40,
Yeah, like this, 40 and 20.
The stay or the sign is attached 40 centimeters.
The stay, the wire is called the stay. Let's see.
We don't need the weight of the sign, the mass of the sign.
We have it. It's 2 kg.
Oh, my bad.
One more strike, and then I'm giving you a 5-second rule. What's wrong? That 0.2 is wrong. Have you drawn it? Can I see? Show me. Yes. Not the scale. But,
Yeah.
You got the idea. Okay. Are you ready to have a look at this now? To draw it? Go on. Did you figure out the mistake? You did? Show me what you fixed. What's that?
Oh, 5, yeah.
Yeah, what's that number? Here.
No.
What's that number? Right. Okay, let's have a look. So, we have the wall here. And we have our sign. And how wide is the sign?
20. 40 by 20.
Getting closer. 40, and here? 20. And then the mass I said is 5 kilograms, 2 kilograms. And the stay is attached 40 centimeters up the wall, so it's here. And the wire runs along here, like this. And it's attached here as well. And this is everything we know, I believe. This is everything. Okay. Now time to draw forces. First force, there's a tension, a force provided by the stay. I'll call that T. And then what happens at the wall here thanks to Newton's third law? What's here at the wall?
Reaction.
A reaction. Which way should I draw the reaction? Should I draw it up, down, left, right, or something in between?
Right.
So you're saying right,
No,
like this.
No, left. Left.
Left, like this.
Yeah.
No.
Yes.
Okay, so we have left, we have right. Any other possibilities?
Shouldn't it be opposite to T?
Yeah.
So,
No.
I suppose it doesn't have to be opposite the T. What do you mean, like
Like this.
this way?
Yeah.
That's what you're saying?
no.
Okay, well we have
He's going there.
3 answers so far, do we? What else is there? Nobody wants to suggest up? Or down? Or northeast? Or it could be this way? Yeah. The answer is, you have to think about this carefully. So imagine it was pressed up against the wall. The first thing is, the sign doesn't go into the wall, does it? So the wall must be pushing back. this way.
Yes.
Also, if I put the sign here, the sign wants to fall down the wall, but does it?
No.
No, so the wall must be also supported up as well. So there's a force up and a force out. So in total, a force this way.
Up, out.
Yes, diagonal.
Yes.
So the reaction force is out this way. What's the name of this point? Yeah, but I mean, in an engineering construction sort of word, what would it be? The part where you attach the sign onto the wall.
Attaching point.
Yep, not quite. But you have the right idea, but give me another word for that.
Point at where it
How many builders do you feel would say, please attach the sign to the wall at the point where it attaches? Come on.
Attachment
That's
point.
important.
You know this because you used it as a verb in the definition of a cantilever. You said anchored at the wall. So this is called the anchor point, or where it's anchored. Anyways, that doesn't matter. So I'm missing one more force in my diagram. What force have I not drawn?
Gravity.
Yeah,
2G.
2G, which is in the middle here. So it goes straight down here. 2G. Okay. Yep. Well, I suppose if to make it extra clear, it's right here in the middle. 2G. And I would like to know, part 1, what is the tension in the stay? What is the tension?
The square root of 40 squared minus 40 squared.
What? No.
Oh,
What? No.
Square, it's like find the length of T and then resolve for something.
No, forces.
I don't know what you're saying right now. I'm going to look at this triangle. So let me just draw this triangle on the right here. This triangle here. What's the height?
40 and 40.
40. And the base? 40. So what's the angle here?
45.
45.
Why?
Yeah, tan inverse 40 over 40.
How did we do it?
Because this side is the same as this side, meaning it has to be 45. No? Doesn't matter. Doesn't matter. So this angle here is 45. So how big is this component? This is T cos 45. What's cos 45? It's 1 over root 2. So this is T over root 2, and here, T over root 2. Okay? Now what I'm going to do, I'm going to take this as the turning point. Why? Now,
Because you can.
because I can, but I must use this as the turning point. Why?
To cancel out the.
So that you don't have to resolve for R.
That's one reason, but there's even a better reason than that. We are completely ignorant of OR. We do not know OR, neither do we know the angle of OR.
That is the only turning point.
No, but we can put the turning point anywhere, remember?
You can make it straight.
It's an equilibrium.
Yeah, it's an equilibrium, so we can put it anywhere. But we must put it here because we don't know the OR, so I don't want to use the OR, so I put it here on purpose. This force, clockwise or anti-clockwise?
Clockwise.
Clockwise, and this one here?
Anti.
Anti. And why do I not care about this one?
Because it's going into the turning point.
Thank you for the added drama as well. Right, so the clockwise turning force, it will be the force, which is 2G, multiplied the distance, which is what?
0.2.
Is it this distance?
Oh, yeah.
Is it?
Yes.
It's not.
Oh, no.
Because remember I said it's the distance that's perpendicular to the line.
Yeah, 0.2.
Yeah, 0.2, yeah. Well, I was trying to trick you and you fell for it. 0.2. And that should equal this turning force. What's the force? T over root 2. And the distance?
0.4.
So calculate on your calculators the t, please. Without mistakes, thank you.
$13.9. Yeah.
Make up your mind.
I'll give you 5 more seconds to confirm your answer before you commit.
13.9.
Please, I'm so tired. Right. What is it?
13.9.
Thank you. 13.9 newtons. Right. Next part. B. What is the horizontal reaction force? So, at the wall.
It says hinge.
Yeah.
Yeah.
Hinge is a synonym for it.
Pivot. Kind of.
Kind of. Yes, kind of. Although hinge is a noun for what that is on the door as well. Okay. We are looking now for the horizontal component of the ore. So this part here. Because you know the ore, if I just go to the side, you can resolve the ore into a part this way, or X, and a part this way, or Y. So I would like to know what is the or X. And there's a very, very easy way to work that out. What is it? Can anyone see?
2G
T over root 2.
Why?
Because we found out that T cosine 45 is T over 2. Because this is going this way, and it has to be equal to R.
Or
There
X.
is opposite direction. Yeah, RX.
You can say the force to the left equals the force to the right. So in this picture here, there's only one force to the right. What is it? Or X to the right. And here there's only one force to the left. What is it? The T cos 45. So that's equal to T over root 2, which equals 13.9 over root 2, which is, please? No. 9.8. And finally, or not finally, part 3, what's the vertical force? So here, what's the or Y? Watch carefully, please. Lee, watch carefully, please. The forces acting up. What forces are acting up?
T over root 2.
Yeah, or Y. T over root 2.
Equals.
Or in other words, I'd rather say it like this. T sine 45 plus or Y, they're acting up, should equal 2G. So or Y equals 2G minus T sine 45. What's that, please?
$9.8.
9.8 newtons. Yeah. Okay. Can I scroll down? Well, to here?
Yeah.
Lastly, part D. Lee, are you being good? What?
He took my calculator.
Right. D.
Find the reaction force.
Yeah, find the total reaction force. So how much horizontal reaction force is there? We said 9.8. And vertical? 9.8. So the magnitude here, we have r squared equals 9.8 squared plus 9.8 squared. So r is the square root of 9.8 squared plus 9.8 squared. What's that, about 14? 13.9. 9. And then I also now want the angle. How can I find the angle?
45.
How can I find the angle?
Tan 9.8 over tan inverse 9.8 over 9.8.
Which is 45.
Okay, we just can we say that 13.9 times cosine theta equals the analysis theta and then solve for theta?
Yeah, if you wish. It's not how I would do it. It's your time to waste. Okay, this is a typical, very typical exam question, so please write this one down. And it's, it'd be typical for section A or B.
I wanted to ask you, in the physics exam, the last part we get 6 questions and we're supposed to do 3 of them.
In the final exam?
Yeah.
I believe so.
Is there anything similar for the math?
Yeah, you have a choice as well. I don't remember. I think it might be the same, 4 from 6 as well. I think.
Can we repeat all the time?
No, I can't because you weren't listening. You were distracted. No, I'm sorry, Lee. You'll have to watch the video because I saw you messing with your calculator or phone or whatever. So I'm not going to repeat myself. I'm sorry, Lee. Oh, what? Lee, what do you want me to repeat? Which part?
The last one.
You are most definitely not Lee. So you do not speak for Lee, okay? I know you're his representative, but Lee can speak for himself. Lee, which part?
R.
The last part, is it?
Just occupying the R.
This here?
Yeah.
Yeah. So what we have here, this is OR, this is OR X, and this is OR Y. Is this the problem? Oh, the picture. Yeah.
Yeah, the R.
This is OR Y, and this is OR X.
Direction of R.
Yeah.
No, I think it's...
Oh, it is right. I promise you, it is right. What do you think it is?
Only right.
This way. Oh,
Yeah.
the OR is this way.
Yeah, the
Okay, so, right, hang on. So the T is right, yes? And here, this is right? And then the OR, which way do you want me to draw it? Up, down, left, right?
Right.
This way? Like this? Yeah, okay, so you're saying that this is the OR here. That's fine. So if you say this is the OR, and if I put an S here, if you are right, then my answer should have OR not equals 0, but S equals 0. You know what I mean? But I didn't get 0 here. I got this number. No? Let me think. I know why you're saying this is it's this way, because you're pushing against the wall and it pushes back. But you must also remember it's pushing down. You're not only pushing into the wall, but you're also pushing down the wall. Because if I try to hang something here, yes, the wall pushes back, but also it wants to slide down. So the wall must be pushing up. So what happens is, you have something like this on the wall, okay, and you attach it to the wall like this, yes? This is pushing out, but also this bag wants to go down. So this is also pushing up. So you have an up and an out. So it's diagonal.
So that's our lots reaction was like this two forces together.
Yeah, it's like two reactions. So this OR is the horizontal and the vertical reaction put together to make one.
Okay.
Yes? Good. Good question. Yes? Okay. Do you need to finish writing that down? You have this? Yeah. These questions are a little bit difficult, I know. It's important to practice them. Okay. Right, here's some I want you to try for a couple of minutes, please. And then I think what we'll do is, I don't think you'll have enough time to do them now in class because you can see they take a while to do. So you just try them for 5 minutes and then we'll just have a start at the next lesson. You can finish them at home and then we'll do the answers next time then. Okay? Alright.
Can I go to email?
Can you do